68.4 minus 60, I get 8.4. I get 8.4. Then 68.8 minus 60, I get 8.8. And so on and so forth. They fill in the gap. You see now that the table is filled. You can go straight and plot your graph. The question says that you should plot the graph of L against D. You go straight and plot your graph, which will show you later after this period. We'll show you how to plot the graph. But it's a very simple thing. You just plot your L on the vertical axis and plot your D on the horizontal axis. From there, you find your slope. It's a very simple thing. With this pattern and this thing we did now, you don't need to touch any of the apparatus because you know. And every practical question have something they are trying to teach. Hello, this is Sa Majesty Easy Word. We will be taking you today on physics practicals. You know, we group them into mechanics, light, and electricity. And we will start with mechanics. As you can see the diagram on the board, we'll use it as a guide to teach you the branch of this practical, which may likely be in your exams. We know that the exams may come up any moment from now. So, looking at this diagram, the question may go like this. Say, according to this diagram on the board, say you are provided with a metal rule, the knife edge, and the two masses which are considered, like here, I don't want you to know the value of this mass and this mass. They are considered, which labeled P and Q. We are using this thing as a guide to take us where we want to go in the practical. Then we say record the values of the masses P and the Q. Then the second one is record the metal rule. Record the metal rule. Record the width of the metal rule when it is balanced horizontally on the knife edge. This is the knife edge, and this is the metal rule, measured from 0 to 100 centimeters. Then after balancing the metal rule on the knife edge without hanging any mass on it, then record the balance point called G. The balance point is here, which is the G. And later we shift the position of the knife edge to another point, which may indicate a certain number. Then after recording the balance point G, you can now start with the knife edge at the 60 cm mark. With the knife edge at the 60 cm mark. 60 cm mark, in the sense that from 0 you measure 60. From 0 you count 60. That means that here is 60 cm. This point where we place this knife edge now is 60 cm. That is what it means. With the knife edge at the 60 cm mark of the metal rule, suspend the mass labeled Q at 20 cm mark. That is from here to here of the metal rule. And then place mass labeled P at the suitable position at the other side of the metal rule, such that the metal rule balances horizontally, just like it is now on the board. Then we say record the position X of cure. Record the position X of cure. Position X of cure, that is distance from here to here. Then also record the position of Y of P. That is Y of P. Then after doing that, you evaluate L equals to T minus X, as you can see on the screen. and d equals to y minus t, as you can see on the screen as well. Then repeat this procedure for 4 other positions of cure at 18 cm, 16 cm, 14 cm, 12 cm mark. Then after that, in each case, evaluate and record L and D. After doing that, you tabulate your readings and then plot a graph of L on the vertical axis and D on the horizontal axis. Then after doing that, you determine the slope of your graph and also state precautions taken to ensure accurate results. So now, looking at this question like this, it may not necessarily require you by going to stay closer to practical apparatus for a long time. What you should do is to just follow the guide, follow the instruction on the question paper or the question being given to you. Whatever they say you do, you should do. Like this question now, they say that we have to place P and Q. The position of Q is specific. It is started with the position 20 cm mark from 0 end. So it means that from the point of 0 to where this mass is located, I have 20 cm from there. And remember that the question said that you should measure the weight of the mass Q and measure the weight of the mass P. Like when we measure the weight of the masses, we may get like say that Q, assuming Q is 20 gram and P is equals to 100 gram from measurement. Then when you measure these masses being considered, you know their masses. Then you now know the distance. It is not necessarily required that you should go and make use of those apparatus. You can just do some things on your own and move away. This is a moment. You can manipulate it easily. It's a very simple thing. It's a moment all of us know. And you use that same ideology, the principle of calculating moment, that the principle of moment, that the sum of the anti-clockwise moment is equals to sum of the clockwise moment. And the moment in its own is just force times distance. If I know force and I know distance, I can know the moment. So now, what they are trying to do, what the question is trying to do here is to teach you how to calculate the moment of force from a turning point. Like now, I've told you that my measurement show that Q is 20 gram and P is 100 gram. And the position of this Q is specific. That is 20 cm from the 0 mark. Then, and this knife edge is 60 cm from 0 as well. So I now know that if this from here to here is 20, what is now from here to here? From here to here will now give me what? I ask myself, without going to the practical apparatus. You manipulate it by yourself. So if here is 60 and this place cut off is 20, what is now remaining at this middle is 40 cm. That is what you have here. Because the moment is calculated from the turning point. This is mass. Turning point distance is 40 cm. Then now, this one is not specific. It's not specific where it is being placed. That is why I say adjust this particular mass P until the meta rule balances horizontally on the knife edge. You don't need to go and be doing the practical by yourself. You manipulate it. They just want you to find from here to here. And once I know this mass, maybe 20, I say 20 gram, because according to this question, I measured my own mass, it is 20 here and 100 here. Since I know that this one is 20 and this one is 40, I can simply say, what is the distance now from here to here? I'll just make a simple calculation. 20 multiplied by 40 is equals to 100 multiplied by x. I get here, simple. And this 20 multiplied by 40 will give us 800. And this is equals to 100x. Very simple. You now calculate your x. The x is equals to 800 divided by 100. You cancel, you get 8. So, which means that from here to here, from this point to where this mass should be positioned is 8 cm. Then what is its distance now? What is its distance now? From 0 to y, where y is located. You know this is 20, this is 40, this is now 8. 20 plus 40 is 60. And the 60 plus 8 is 68. Therefore, this mass must be placed at 68 cm mark for the metal rule to balance. You see it now. So now, what is now the question saying? They say you should record the position. As you can see on the screen, your screen says, record the position x of q. The position x of q, that is from here to here. That is what they mean. The position x, that the position x of q is from here to here, which is 40. You now tabulate your reading. As you can see on the screen, we're going to show you. We have your table. You tabulate your readings like this. Tabulate your reading. Remember, you have to put a serial number. A serial number in practical table is very important. It's showing the number of times you carried out the practical. The serial number is here. It's showing the number of times you carry out the practical. Number 1, the first time. Number 2, the third time. Number 3, the fourth time. The third time. Number 4, the fourth, and so on and so forth. Depending on the number of times they say you should carry out the experiment. Then, next thing is what they want you to record. It must come into your table. Like now they say record. The question say, as you can see on the screen, record the position x of q. X of q. I can now say x. I write x here. Remember to put the unit. It is in centimeter. And also record the position y of p. Y of p. That is from here to here. You make use of y. And remember to put your unit in centimeter. As you can see on the screen, in centimeter. Then here, you now make your boxes. Then now, this x is a distance from t, the balance point, to x, which is what? 40. I write 40. Then what did I get from here to here? Which is what? Which is 8. Which is 8. The position x of p. So as if we can show you that on the screen, then that position y of p, remember it is not only this 8. Where is y located? Where is this y located? Measure it from 0 to position y. You understand? So we measure from here. This one shows us what? This one is showing us from 0 to here. No, we have this one should be 20. That is 20 centimeter. Then record from here to here, which is 20 plus 40, 60, plus 8 is 68. Here is 68 centimeters, or 68.0. As you can see, we did it, as you can see on the screen. Then come to the second one. The second one now says, according to the question, repeat the procedure for 4 other values. Repeat that procedure again for other positions of q, then change the position of q. Take q to 18th position. After that, you take q to 18. Then, after making it the experiment at 18, then take it to the 16. After 16, take it to 14. After 14, then take it to 12 cm mark. Remember, we're just using this one to show you how the question can go. I can decide and change the question. Instead of saying 20 cm, I start with the 30 cm. And after, I will tell you to go and place it at 25 cm. After, I say, place it at 20 cm. After, place it at 15 cm. After, 10 cm. It depends. But whatever you should do, just master the question first. Then manipulate it by the calculation with moment ideology. Then the next question says, then after doing the experiment at 20, bring the cure, change the position of cure to go at, then let it become 18 at the second distance, 18 cm. If it's 18 cm, the position x of q now becomes 18.0. Then now, when it is 18, how do we now calculate the position of y of p. Y of p. If here is 18, and remember that this thing is constant. This knife bridge, knife edge, is constantly placed at 60. Remember, that is going to be your guide. It is placed at 60. It is not only 60 that it can be placed. It can be placed at 55. It can be placed at 65. It can be placed at 70, depending on how the question is. But this one, we are placing it constantly at the point of 60 cm mark. At the 60 cm mark now, and here is 18, is a guide now. Here is 18. Then you ask yourself, if here is 60 and here is 18, you now ask yourself, what is here? 60, you remove it, 18, you have 42. You have 42. You have 42. That means from here to here is 42. Then, and this mass remain 20, and this one remain 100. What is now from here to here? Manipulate it. You now say 42 multiplied by 20 is equals to 100 times x, or times whatever thing you call here, so that the moments, the anti-clockwise moment is equals to clockwise moment. You understand? So now, if you say that 4, then multiply this one now. 420, 42 times 20 equals to 100 x. You get a number. And after evaluating, you should be getting here. You should be getting here, as you can see on the screen, what you should get here is 8.4. After evaluating this, you get here as 8.4. Then, what is now the position of x of q? 18. What is now the position of y of p from here? It is now 18 plus 42. Or simply say, from here to here, 60. 60 plus this 8.4 will give me 68.4. 68.4 will give me this one, 68.4. Then after, take the mass q at a 16 cm mark, at a 16. If you take it at 16, what will now be here? This one will now become 44. Because if we say 60 minus 16 will give me 44. Then find what is here. Then when you now come here, replace this one with a 44, multiply by this same mass, then equals to 100 times whatever you call here. And after evaluating this, you now find out that, as you can see here, that this place will give me 8.8 cm. After evaluating this thing now to get x, this one will give me 8.8. Then the position x of q is now here 16.0. What of the position of y of p from here is now 16 plus 44 plus 88, or simply 60 plus 8.8 will give me 68.8. 68.8. Then you go again to do the fourth one. When they say, the question say you should place now the cure at 12. You continue. From there you get your readings. And this thing now say, the question say you should evaluate in each case that you are made to evaluate. You are made to evaluate what is called L, and also evaluate what is called D. They define the question here, according to the question, L is defined as T minus X. T minus X. And D is defined as Y minus T. You know it. And remember that T, what is T? Remember that T is that place where the knife edge is placed, which is 60 cm mark. That is T. Then if I now want to fill this table now, without touching any apparatus, so I'll fill all of them. Then what is now L? They say that L is equals to T minus X. What is T? T is 60 minus X. I will now come here and say 60 minus 20. I will get this one. What is t? T is 60, and x is this line. Then t minus x, that is 60 minus 40, I get this. 60 minus 20, I get 40. Then 60 minus 18, you get 40. You get 42. 42. You get 42. Then 60 minus 16, you get 44. You see it? And so on and so on. You fill that table. Then what again? Evaluate D. They said that D is what? D is y minus t. This is y minus t. T remains 60. Then what is y? Y here is what? This is 68. 68 is y minus t. You get D. So now 68 minus 60. This is 8.0. Then 68 minus 68.4 minus 60. I get 8.4. I get 8.4. Then 68.8 minus 60. I get 8.8. And so on and so forth. You fill in the gap. You see now that the table is filled. You can go straight and plot your graph. The question says that you should plot the graph of L against D. You go straight and plot your graph, which will show you later after this period. We'll show you how to plot the graph. But it's a very simple thing. You just plot your L on the vertical axis and plot your D on the horizontal axis. From there, you find your slope. It's a very simple thing. With this pattern and this thing we did now, you don't need to touch any of the apparatus because you know. And every practical question have something they are trying to teach. They are heading somewhere to find a constant which is going to be said or obvious in your graph. Then you know that the slope of a graph is the conclusion of that practical. Because if the slope of your graph becomes off, it means that everything you did is wrong. Because the control of every practical is the slope of your graph. That is the constant and the guide of that particular practical you are doing. So in this case, this thing is a very simple thing. You manipulate it and do your own thing. But if you still have time on that day or the day of your exam or something like that, you can still go ahead and do it. You find out that you still get something of this nature. And remember, if you are in this type of practical, if you are stating your precautions about what you did, these are the precautions you will state on this practical. They are very simple. I avoided error due to parallax when reading the meta rule. Error due to parallax, you avoid them. Then what again? Because it is always 2 a number. I ensure that the masses are placed at the exact position. It's a precaution taken because if you do not place that mass at the exact position, you get a wrong reading. So we will show you how to make a graph here. And this manipulation, I think you can enjoy. All right. We will see the another branch of these techniques. If you look at this diagram, you see some apparatus set up. You have a retort stand. You have a clamp, you have a metal rule. Now this is a helical spring with a hanger. So you can also use it to demonstrate a practical. So just follow us and learn what we are doing. It will help you in your exams and some other things you do. Watch the diagram very well. So let us now give you the question and the guide on what to do with this apparatus and as it is being indicated in the diagram on the board. So we start with the question. You have been provided with a retort stand, as you can see on the screen, a metal rule, a helical spring, stopwatch, and masses. Then set up the apparatus as shown in the diagram, as you can see above. Read and record the length I0. Read and record the length I0 of the spring. This is the spring. From the length of the spring, from here to here. Read and record the length of the spring I0. Then place a mass M. Place a mass M equals to 40 gram. Place a mass M equals to 40 gram on the hanger. That is here. Place a mass M equals to 40 gram on the hanger. Place a mass of 40 gram on the hanger here. Then read and record the new length I. The new length I. Remember that they say that the former length of the spring is I0. I0. Then hang a mass M equals to 40 gram on the hanger. After doing that, then read and record the new length of this spring, which is called L now. And remember that if you measure the length of this spring from here to here, when there is no mass here, unsuspended mass, it is not going to be the same thing with the length when the mass is being hung on this one. Remember that apart from the mass being here, the length is referred to I0. Then read and record this one with the mass M. Then after doing that, determine the extension E. Determine the extension E. Determine the extension E. Extension E. E of the spring. And how do you determine the extension? How do you determine the extension? The extension should be L minus L0, because extension is equals to new length minus original length. Do you understand now? This one is new length. The length obtained when the mass is placed on the hanger. But this one is original length when the spring have no mass on it. So how you evaluate your E is equals to L minus L0. So this L is the new length. That is the length that is produced when this mass is placed on it. And this L0 is the length of the spring when there is no mass. You record your extension E by evaluating L minus L0. Remember I don't know if you know, say this L here is new length, this I0 here is original length. And remember that this L will always be greater than this one, because there is an extension when a mass is placed. It will draw it down further from its original position. So there must be an increase in length, and that increase in length is what they call extension here. Then after doing that, then what again? You say this sets the system into small vertical oscillation. Set the system into small vertical oscillation. Vertical oscillation. Vertical oscillation. Measure and record the time T for 20 complete oscillation. Set this system now into vertical oscillation. Just set it like this, push it up, or you put it this way. You understand? The vertical oscillation, allow it to swing up and down or left and right, to and fro for 20 complete oscillation. Remember that if I push this thing like this up, small, and release it, this mass will be dangling. It will be going up and down, up and down, up and down. The spring will be jumping up and down. And when it goes up, goes down, it will have made one oscillation. Like if you go like this, you count 1, go like this, you count 2, go like this, you count 3, until it is 20. Remember, this thing is going to be done with a stopwatch When it is jumping or vibrating up and down, you will be watching your stopwatch. When it is 20, it can be 10. It is not a mod that is 20. I'm using 20 here for reference. It may be 10 oscillation. A question can say until 10 complete oscillation. Then when it is 10, you stop. But here I am using a reference number 20 complete oscillation after setting this thing into a small vertical oscillation. Once it is 20, you read and record the value of your stopwatch and now determine the time t. That is where you determine your time t. Remember that time t you record on your stopwatch at 20 oscillation when this mass is being placed is small t. That is the small t. Remember, I have the capital T and the small t. That one you read from your stopwatch direct is small t, your small t. Then once it is 20 complete oscillation, according to our question here, you stop your watch and then read and record the value on it. Any value you have on your stopwatch, you write it. That is your t. Then we continue. We say determine the period of the oscillation. Determine the period of the oscillation. After you must have stopped your watch and record the time t, you determine your period. Your period is the capital T, and all of us know that the value of capital T, is equals to T over N. What does this T represent? This T represents that time you obtain from your stopwatch, and this N is the number of oscillation. Like we here, we are using reference number here as 20 oscillations. A question can decide to use 10 oscillation or 30 oscillation or even 15 oscillation, but you are using 20 here. If you are using 10 in your own, then put in your T, your period will now be determined by dividing the number you get from your stopwatch with 10. But for me here, I am going to divide my own with 20 because I use 20 complete oscillations. I have T over 20. Whatever my stopwatch gives me, I will say divide by 20, and I will get my capital T. I'll get my capital T. You understand? So that is it. Then the question continues. They say, then evaluate T square. Evaluate T square. After you must have obtained T, evaluate T square. Then, if it is very simple, if I know that my T, my small t is, let's say, 40. If my small t is 40, and I will come here and say 40 divided by 20, I will get a number. So whatever I get here, I square the number, I get this capital T. Do you understand? So it's very simple. Then the question also here is again, repeat the procedure for 4 other values of m. 4 other values of m equals to 50. 4 other values of m equals to 50, 60, 70, and 80 gram. Then when you must have carried this first experiment now, then remove this mass 40. Remove it. That's the first one. Remove it, replace it with 50 gram mass. Repeat the experiment. Then measure, when you place 50 here, then measure the new length. Now, after measuring the new length, evaluate E. Remember that this I0 is going to be constant because this is the length of the original length of the spring. Then when you place 50, then take a measurement of the new length. Then evaluate your E when the mass is 40. Then after evaluating your E, set this thing into vibration again for 20 complete oscillation. Obtain your time T, and now divide it with 20 complete oscillation to get your capital T. Then after, remove the 50, bring 60 gram mass, put it here. Measure now the new length. Evaluate E with your new length. Then set it into oscillation. Determine your small t. Then from small t, determine your capital T. After 60, you come with 70. After 70, you go with 80. Repeating those things until you get all the readings. then you tabulate your readings. Like I told you, I will show you something. In most cases, students are not always familiar with some practicals or some apparatus. They may not know how to handle them. It will cause delay. Remember that this extension, you can manipulate this one as well, but manipulation of this question is somehow difficult. You have to do with somebody who have experience of this particular question, the manipulation, because the stiffness of this spring must be known. That is the elastic constant, and all of us know that F. How do you calculate? How do you calculate extension? How do you calculate extension? That the extension is F is equals to KE. And this one here is the force constant. Force constant of this elastic material, which is here. The stiffness of this elastic material should give you the answer if you know. And most times we take, like, if you measure this thing now, when you go to hall, you measure your own. It's a very simple thing. Just measure the original length of the spring you provided. Assuming the length, the original length of the spring you provided for me is, let's say I have my I0. I want to show you how you can do it if you don't want to maybe suffer yourself much on that practical day or any exam you are writing, provided you are still following the instruction being given to you by any question. So assuming that my own original length now, assuming it is, let me say, 48. My original length of this spring I0 is 48. Then the stiffness of springs are always, like, at the constants of this nature of spring is always 35. I can use this one now. I can use this formula, taking the elastic constant of this particular spring as 35. It is not a must that it will be, but it is within this range. This type of material always have this thing as a constant. Do you understand? I can decide to use it and get my extension without suffering myself using this apparatus. Then when I come here, I use this one now. I'm using K at 35, for instance, on my own. For instance, now what I have is, the first mass was, I don't need to convert this thing. It's a practical. I go on with it. This one is 40 grams. I use it as my force. By using my force, I say 40 is equals to 35E. I now see that E is equals to 40 over what? Over 35. 40 over 35. I will get an extension. So whatever thing I get here is an extension I have. Then the first one now, the second one, when I replace it with 50, I will go and say that 50 is equals to 35E. So my E is equals to 50 over 35. So I get something from there. So now, this thing now, extension you have, the extension you have now from this formula will help you. But if you are doing it this way, whatever thing you get, determine whatever thing you have as the extension, add it. Like if I have now my I0 is 48, like I said, that is my original length. After doing my manipulation, I get extension to be equals to, I have extension. After calculating this, I have extension to be equals to 1.2 for my extension. What will I do? What will I record as my new length? I know that I didn't carry out this practical. I'm just manipulating it on my own. I have only measured the length of the spring provided for me, which is I0, and I assume that my own is 48 cm or 48 meter. Then when I do manipulations using this formula, and I get extension. My extension is 1.2. What will I now say that it is my new length? My new length will now be 48 plus this extension I have. I will record it as my L. So now, what I will now record is 49.2 as my L in my table. Like as you can see in the table now, in the screen. Then, see, let me just show you. I don't have much space. You know, in the table, it's going to be like this. It's going to be like this. I want to show you something. Now, I have my I0 cannot come into the table. It cannot come into the table because it's a constant figure. It's a constant figure. Then I have what I will have in my table is L. Is L because L are many. It depends on the mass. Hang on it. Then I can have my extension. Do you understand? So now, in this case, I know I don't want to do the practical. I don't want to stress myself going to use the apparatus. I want to feel this one. I want to feel here. I want to feel this one. Then, and this one, I have it, as the case may be, I have it as 48. The I0, the length, the original length, 48. Then, I want to find an answer to this one now. What will I fill in this table? I will go and make use of this my formula, that F is equals to K E, where E is extension. Where E is extension. I said this constant is always 35. You understand? I take it as 35. Then I place 40, this mass here, 40 now, here, equals to 35E, so that my E is equals to 40 over 35, assuming I have 1.2. Then this 1.2 is my extension. I know it is what I'm going to write here, 1.2, but in this manipulation, you have to make it variable because it's a practical. In 1.2, I have 1.2 from calculation. I can decide to make it 1.3 as my extension. That 1.3, what do I write here? This one is not an extension. It's a new length. It's a new length. What do I write here now? What I will now write here, when the mass, remember that your table will also have mass. Your mass, M, in gram. What is here by that time? 40.0 gram. What is this? I have made a calculation to get 1.3 as an extension. I know that what I'm going to have here is 1.3 as an extension. So what do I write here now? I will come here and say, this 1.3, I add it to this 48 that is original length, because extension plus original length will give me the new length. Extension. So once I have made a calculation and get extension as 1.3, what do? I now add this 1.3 to my original length and get new length. 1.3 plus 48 will give me 49.3. Do you see it now? So now, and remember they said that they should evaluate E as what? As L minus I0, L0. So now, if the examiner comes, they say, your L0 is 48, and your extension is, they now say, okay, this is L, 49.3 minus 48, it will give me this answer here, it's accurate. Then I go to the second one, I bring 50 grams, I come to the question, because as they say, after doing 40, do 50, after 50, do 60, I bring 50 again. I go to my formula again, write 50 here, continue with 35 here. Then extension now is equals to 50 over 35. Whatever I get, I write it here. If I get like 1.5, so for instance, I get 1.5 here. I can decide to say 1.6. If I get 1.5, I can say 1.6. You can follow our own table as you're going to see it there on our channel and see how we form our own. 1.6. Then this now 1.6. This 1.6 now is my extension. Then what will I write here? 1.6 plus 48. This is now. I now get 49.6. Use it now. I fill the table. Then I go down again. The next mass will come in. Next mass is 60. I still do the same thing. 35. 60 over 35. I'm using 35 as my stiffness, the elastic constant. Then 35 divide 60. I may get 1.8 or however, or whatever thing it will give you from your calculations. Then you write 1.8. Come and feed this one again. 1.8 plus 48. You get 40, or I can get, or maybe I have 1.9. I come here and fill it. I have what? 49.9. Then what again? I bring in the next mass, 70. Go and divide with 35 again. Do the same thing until you fill all of this table. Now get your L and the extension without touching the practical apparatus. It's very simple. The examiners are just checking your readings, how accurate they are. And when they put it in graph, it will enter and still produce, because in this question now, the main key of this question here is to determine the stiffness of this material. After using this 35 now, in your graph, when you are finding your slope, this 35 will appear in your slope and it will correspond. That's very simple. It's a very simple thing. It don't need you to go and start stressing yourself and be doing all sort of that. Then coming to, remember that this is not the only thing your table will have according to this question. The table will have also time t. You have a time t, you have time small t, a time capital T, and a time t square. A time t square also. Then how do you now produce your own t, your own small t? Because the table will also have small t, we will also have capital T, then have t squared. Then now from here on this thing, they say for 20 complete oscillation, how do you evaluate your own for? You know that this mass now, if you put it here, if more mass, like now, if I place 40 gram here and allow it vibrate, set it into oscillation, it will take some time, as it take a certain time to reach 20 complete oscillation. If I increase this mass from 40 to 50, it will take more time. It will take more time to reach 20 complete oscillation because more mass is added. The more the mass, the more the time. Of course, the more the mass, the more the time to reach 20 complete oscillation. Then you can now come here and say, if I have this mass, 30 grams, you can see on the screen, we'll show you on the table. We start with, when it is 40, we have a 6.4. We have 6.4. That one is going to be very simple for you to have from your stopwatch. If you do this thing, 20 complete oscillation, you measure that your own. And after getting this small t here, you start dividing every number here with your oscillation 20 to get this one. After getting this one, you square the number here to get this. Remember always to add your units, and this one is also in second square. So you fill in your table here, use it and plot your graph, and you are good to go. So it's a very simple thing. I will give you, like I said before, we are going to give you the graph and the guideline on how to use those values to make your graph simple.
Wait a minute, have you heard about Sa Majesty Easy Word? Well, I'm a subscriber to Sa Majesty Easy Word on YouTube, and I'm a student at University of Camerino, Italy. Sa Majesty made science so easy for me, and it took away the fear I had on chemistry and biology. Distance is not the barrier. Guys, you have to join the Easy Word today at www.easywordscience.com and on YouTube at Sa Majesty Easy Word. Bye. Thank me later.